Hey there, I hope to find you well. So today, I bring you one of the items on my wish list to review. If you are a regular viewer, you might know that one of my favorite super cheap and kind of toy oscilloscopes is the DSO-150. This oscilloscope was first created by JYE Tech and after cloned by almost every manufacturer of cheap oscilloscopes in the internet. Mine is a clone also. So when they released this new Wave2 oscilloscope some months ago, I really felt that I had to test it, but always postponing because of the price that seemed a bit high for this fellow. So with your help, through the affiliate commission I got from you guys when using the affiliate access links and the affiliate link in the description, I decided to buy this unit. By the way, did I mention how thankful I am from your support? Yep, I really appreciate all your love and support, so thank you again. Moving on, I've been playing around with this baby all day and I'm going to pause here so you can see the features and the tests I made. This is really a cool device, or is it? Stay tuned to find out. Okay, as usual, let's see what comes in the package. Let me just open it. We have this delivered in this white package. Inside we have, well, this seems to have already been used. The plastic is all, yeah, it seems used plastic. Yeah, the protection is also very bad. Okay, this is not good news. Let's see. Well, the screen seems to be intact. I don't see any scratches in it. I will take this in a bit. So we have a paper that seems to be the user manual. It's a A4 paper. Yeah, we see it seems to have XY modes, 2 channels. Yeah. Okay. Let me see if there is anything else in here. Okay. We have a lot of things going on in here. Let me take it out. Okay, box out. So we have 2 probes already with the rings on it, a blue and red one. Let me put the top on the probes. This is the P6100, the normal, more than standard. In these cheap oscilloscopes we have this is a micro USB. It's not yet USB Type C. Too bad. And we have a pen. This is interesting. Also a flat cable to connect. I think this is the expansion port. Yeah. So as first impressions, this is very similar to the DSO 150, this one. The shell, the knob, everything seems very familiar. Yeah, the size and everything. And in terms of what you get here, you have 4 function buttons. You have this knob, this little knob. It's clickable. Okay. So unlike the DSO 150, the Wave2 has 2 channels. And in here you have the output of the signal generator. Not signal generator. This is the signal output for calibration of the probe. The signal generator, and this one has a signal generator. The output is in this expansion port, if you can call it like that, where you have a cable and with a diagram that is, I think on the user manual we have a diagram. Yeah, on the output. So we have here the external trigger signal and also the function generator signal on port I believe it's 8. This is very small letters. Yeah, I don't know. Port 3? I don't know. So the output is done on this port. I believe it's 3 or 4, I don't know. So you just have to see it. They call it auxiliary port. Anyway, so this one, the DSO 150, it's one of my all-time favorite very low budget oscilloscopes. I believe this cost me around 20 euros, or not even so much when I bought it, but the prices increased a lot. One of the problems that this one has, it's not having the auto function, the knob and clickable, but even so it's very easy to work with it. So this one is one of my most loved oscilloscopes of the small ones. There are faster ones right now, but yeah, so I was quite curious to see how the successor of this one will be. This is the Wave 2, as I already mentioned, and it has several things different, and I will show you in a bit. First of all, let me show you that you have here a small switch, and this cannot power on until you power the battery. Let me see if I can do it with this scissor. It's in here and it's not very accessible. So I think I managed. Yeah, and right now you have the battery on. We have this Wave 2 logo, some firmware information and board information while booting. And yeah, this is very similar to what you got in this one. Let me just power on my power supply, and I don't have battery in this one. We can have a battery, you have to do some modifications to have a battery. Okay, so I have power in this one. Let's see, it's down here, we have a button. Also, this is a clone again, but if you see the screens, they are pretty similar. The Wave 2 has a little more, well, it's polish. You have round corners around these areas. Probably is faster because I don't know if the camera captures, but it has more flicker than this one, so the processor is more recent, probably is faster, also the refresh rate. And yeah, I don't know, also in this I can disable the info by pressing here for a while, but on this one, since we have 2 channels, I believe that we have to go to the menu. Okay, let's see how the operation of this oscilloscope is, and yeah, so let's connect this to my function generator. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code. And if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Okay, so the first thing I will show you before going to the user menu, since it is easier to show with a signal, is connect this to my function generator. Sorry for the confusion here in the screen. So I have my oscilloscope already set up here. You can see that I have 100 Hz in each channel, one with curve wave, one with sine wave, the first one. So starting from the top, we have here the position, the horizontal position in the buffer. Let me show you. You just use the knob to change it. Okay, very simple. The second one is the battery indicator. Right now it's almost full. And the third one is the signal generator output. It's not signal generator, it's the signal tests, the test signal output. This right now it's a level indicator, and to change that level, because right now it's 3.3 volts I think, but you can go from 0.14 to 3.3. So you use a long press on F1 to change that, and that's it. As you can see, in each of the channels we have two channels. We have three values that can be changed. We have the amplitude, the coupling, and the position, the offset position on the screen. So let's start by the first one. We can change the offset, the amplitude of the signal. Okay, so F1 and F2 move the cursor between channels, and F3 move the value inside the channel. DC coupling, AC coupling, as you can see it changes, and also the offset. So that's it. The next one you can move to channel 2 and also do some of these changes. We have here the time division. Right now is 2 milliseconds. Okay, you can change it. Let's increase here a little more. Okay, the square wave, and change the position to be more clear. Okay, so yeah, very simple to use. And also the next one, it's the trigger. For the trigger you have the trigger modes, rising edge or falling edge. This is the slope, and this one that you see here is to change the trigger channel. So right now it's on channel 2 and channel 1. As you can see, this is as simple as you can get, and there is no way this can be simpler. There is a huge gap in this oscilloscope that the DSO-150 had to. We don't have auto function, so you really have to manage to sync the signals manually, because you don't have an auto function. Okay, the thing that this oscilloscope has is that you can also use, but it doesn't work very well. You have to press a lot in the screen, but you can use the touch screen to change the values. For example, now I'm trying to set the trigger. You can choose like this the options. For example, if you want to move the channel up and down, you can do it. It's not very sensible. It's a bit hard to manage this. Okay, like I want to change channel 2. Yeah, you can do it, but yeah, it's not so user friendly as it should. I don't know how we change. Okay, just do it like this, I think. No, this is changing. I don't even know how to change the... Let me change this again. I don't know why the trigger it's not on where it should be. As you can see, it's a bit hard to use this to manage. But this is an improvement, I think, over the DSO-150. At least it's some innovation. They try to innovate a bit over something that is very stable and has a lot of years being good in that range and in that category. So yeah, we power on in this button, as you saw before, but to power off, the manual says that you press this for 2 seconds. It seems not to be working, or at least I don't know, maybe it's I'm doing something wrong, but even so, the big difference between the Wave2, obviously other than the 2 channels and the function generator, is that you have this menu. On this menu you have the clear offset. It's some kind of reset function. Also you have measures, and you can put the measures that you want for each channel on the screen. Okay, you have here channel 2, channel 1, and the measures. You can select the measures that you want. It works pretty well. Let me change this. Okay, you have also the signals generator, but I will go there in a bit. So clear offset. I don't know if I can do this clear offset while having something connected to the oscilloscope. Probably not, but yeah, it seems that it worked. So okay, let me move this again to a better position. So we have the default, and we have the WF memory also. We can save several things in memory, so, and retrieve it. Okay. Auto off. This is to power off automatically on 5 minutes, 15 up to 2 hours. User defined time or never. I don't change this. And also, if you have roll or scan in the signal. The persistence, okay, you can create persistence also. Let me see. As you see, we have persistence in here. I changed the trigger, so yeah. Let me take this off. And this is the YT mode, and we have the YX mode. Okay, in the YX mode, let me see if I can oscillate this a bit. We don't need much. Let me just change something like this, and it's already oscillating. We don't have a lot of area, so let me increase this to 1 volt. Okay, should be enough. Okay, yeah, let me try to set this up. Okay, so we have something already spinning here. It was not what I was trying to do, but yeah, you can see that we have XY modes in here. Okay, let's see if I can change this. Okay, anyway, as you can see, you have the XY mode. So that's it for now. I have to put the modulation again in place without modulation, and the trigger, where is the trigger? Okay, let's trigger this, and yep. Okay, so we are again with a nice image on the screen. Going back to the menu, we have also an info screen where you can download the user manual. It's a very small manual, so you don't have much. We have voltage internal, voltage external, the model, the main, and the keypad. So that's the information you have. Also here, identification and the board. You can do a reboot, or you can power off, and the only way that I found out to power off this yet, it's using this one. So you have this screen, you can always cancel. Let's do a reboot to see what happens. Yeah. Okay. This oscilloscope supposedly has 200, the analogic bandwidth, it's 200 kilohertz per channel, and has a sampling rate of 1 megasample per channel. Yeah, it's interesting. Okay. Okay, and in terms of oscilloscope, that's it. Nothing much more to show here. I don't know why they chose the micro USB. Nowadays everything it's USB Type-C. It's the standard. So this doesn't have so much time to that they have to use the other one. Yeah, this seems a nice evolution from the other one, but for me it has some serious issues, and I will discuss that on the wrap up of this video in the end. So okay, I think in terms of oscilloscope that's it. Let me just show you the signal generator. Output is like this. We have the what is going on the screen also, and we have here the signal A and the signal B output. For using the signal generator, again, I have to have this connected to something. I don't have the board to create a USB to wart serial. I think this already converts to wart. But anyhow, I will not test that part because I don't have here what it takes. So yeah, that's it. Okay, one thing I can test is the probe connected to the signal generator. Okay, I have two. Let's try to take one out. Sorry the confusion, but yeah, and we will disconnect my function generator. Let's connect this to the probe 1 and XT mode. One thing that I didn't show you is if you want to disable one of the channels like this, you change the amplitude like this until it's off, and that's it, how you disable a channel. Okay, so let me show you like this. Okay, it has something in here. We connect here, and I think the probe it's well compensated. Let me see. Okay, we need to bring this down a bit. Yeah, it might be better compensated, but it's not bad at all. I'm not even going to try to compensate this. One of the things that I already noticed is that I will take one of the channels off like this one. So let me connect here again my function generator. Right now I'm going to put on the screen 100 kilohertz sine wave. Sorry, I was on the wrong channel. 100 kilohertz sine wave. Okay, we have a signal. Let's try to clear offset here, aligning vertical position. Okay, it's more or less an auto, not quite well, but let's increase the signal and move this to, always get this wrong. So right now we have on the screen with 10 microseconds the 200 kilohertz sine wave. I must say that I'm not impressed with this. I don't know why. I was expecting a bit more. Not this one. Let's bring this down and move the trigger a bit up so we can stop this from flickering so much. In terms of time division, this is the maximum that we can get. So single, normal, auto. Okay. Yeah, not impressed with 100 kilohertz. This is the half of the maximum capacity. So let's move to 200 kilohertz. I have one VPP signal right now here. Yeah, this will not impress me at all. Let me see how is the signal with the older model at 200 megahertz. I'm powering up my Rigol DP803 power supply, 9 volts. Okay, so I have a second channel here to connect. Let's see if this is better than this. Okay, let me move to channel 2. Okay, 200 kilohertz. Yeah, so let's see what we have in here, because I don't believe this is anyway better. Okay, let's decrease the division. They are pretty equal. Maybe I didn't work with this for so much time that I don't remember how it really was. So 100 kilohertz in here, and moving the other one to 100. Oops, not this one. And 100 kilohertz. So in terms of performance, they are really very similar. I think this one has better graphics. Maybe maybe what you say, tell me in the comments, but I think this one has a little bit better graphics. The processing, it's not so jittery, but yeah. Okay, even so, in the end, I will tell you better why I have problems with this. Okay, so the next step is the teardown. So let's do this. Okay, so now it's teardown time. Okay, so let's open this. Oops, and power this up. Maybe I should disconnect the battery. Let's see if I can do it like this. Yeah, so battery disconnected. Let me just take this out. Okay, we have 2 boards. Okay, battery out. So the first thing that caught my attention is that we have 2 processors here. The first one is the STM32F103CBT6, and the second one is this one. It's the 32F100C8T6B, I think. You have on the screen the specs. Not sure why, but maybe one is for graphic and the other one for processing the code. Really not sure why. Another thing that caught also my attention is all these connectors here on the side. You have the master wart, the slave wart. Can see exactly what this one is. And the master SWO. What's going on there? Let me see. It's the OWS slave. Okay, so in terms of ICs, this one, the MC34063AG or AG. This is a 1.5 amps peak boost buck inverting switch regulator. Okay, so it will handle the current in here. We have also a CH340, I believe that's N edition. That's the USB serial IC. It is very near here. Normally in this area we should have also a very nice and very used IC for charging, and I'm talking about the TP4056, and I don't see anything similar here. Maybe I'm missing that one. We have here the switch that you must turn on when starting to work, so you activate the battery, the output, the auxiliary port output, and the battery output also. Okay, so in here we have the TL0826, and that one is a general purpose GFET dual operation amplifier. What else do we have? Let me see. I didn't find any documentation on this one, so sorry, I am not able to tell you what it is. And so this one is the connector for the channel or signal analysis part. I will show you that part of the board in a bit. We have here the signal, the test signal. And let me take this around. This is the knob. It has, let me show you, it has this part, this little connector for the knob, and the board, okay, with all the information, part number, and all of it in here. Okay, so let's move on to the second part, to the second board of this oscilloscope. We have a battery with 1200 milliamps, okay, and a lot of dust in it. And yeah, and we have here a lot of stuff going on. First of all, for each channel, I think we have a TL084C, and this is another JFET input operational amplifier, or amplifiers, because we have two, one for each channel. We have also the 74HC4053D. This is a triple two-channel analog multiplexer demultiplexer. Also in the bottom we have in here the 74HC595D. This is with a big name. It's an 8-bit serial in, serial or parallel out. It's a shift register with output latches, 3 states. Okay, so and in here we have for each channel, believe also that's because if you notice you have this one divided, the board is divided. So for each channel you have, let me see, what is this? The 74HC4051D, and that one, it's a 8-channel analog multiplexer and demultiplexer, also 2 of them. And I think we are almost done. Let's see if we have anything else. I think we have this little guy in here. That's let me see. Okay, so this is a CPC 1017, I think, N. Okay, so this is a 4-pin SOP Optomos relay. This is a small relay, one for each channel. And yeah, I think the rest of the things is just MISC condenser, capacitors, resistors. Yeah. So yeah, that's it. Let's wrap this up. I'm back to wrap this up, and I have a lot to say, so keep up. Let me start by saying that JYE Tech does a wonderful job by opening the schematics to everyone and releasing these products in a way others can learn and improve the same products, so they deserve to be supported. Kudos to them. That said, and as a chopper, I am really struggling to consider this device as a viable option. The price is way too high, even considering that they include 2 probes that worth 8 to 10 euros. The price on official JYE Tech AliExpress shop is 103 euros, or around $115. My unit was bought on the AliExpress anniversary. With discounts and delivery, it cost me around 70 euros, or more or less $78. If you consider that you can buy on AliExpress a Z-Wave DSO2512G with 120 MHz bandwidth, 2 channels, function generator, analog output to connect to a TV, and a few more perks for 72 to 85 euros, or around $80 to $95. It depends on the promotion season, the seller, and your location. For example, for me, I benefit a lot if there is a European stock to pay less taxes. For me, the price of the Wave 2 is ridiculous. We have to keep in mind that Wave 2 is a 2-channel oscilloscope that has only 200 kHz per channel, no auto function, and a very restrictive set of functions. The touchscreen is nice, but don't add anything to the general usage experience. It is hard to work, and the general usage is not so easy to work as the DSO2512G. We can tolerate these issues in 18 to 22 euros or $20 to $25 clone oscilloscope like the DSO150, but if you're talking about 80 to 100 euros, it's just a joke. There is a reason for not being cloned yet. It doesn't worth it. It is a nice product. DSO150 already was, but in a different price range. By now, you can understand that I don't recommend this, unless you get a real nice promotion and you are able to buy these on the 35 euros or $40 range. Otherwise, you are better with a JYE or even a FNIXI unit. So, if you are on the market for a tool like this, please remember that you have the affiliate link to buy this device and also the DSO2512G on the description, or you can use also the affiliate access links here in the screen. Again, thank you for your help, it is really appreciated. And if you learned something and this video was in any way useful to you, please smack that like button, and if you haven't already, please subscribe and hit that bell to activate all notifications and be one of the first to be notified whenever I upload a new video. That's it for today. Really appreciate your company, and I hope to see you in my next video. Until then, stay safe. Cheers.